Hi everybody, I'm presenting here my poster about Neuromorphic Extreme Edge Computing Photon Sensor. In this poster that you will see at ICT, we explain our vision about a possible acquisition chain for touch sensors that exploit neuromorphic and parallelized computing to achieve very efficient and on the edge computation. This kind of object, this kind of approach is mainly thought for very computation at the edge. So in the case, for example, of IoT, in which basically we want that the data that are acquired by a specific sensor gets pre-processed and pre-digested by a system that is supposed to be very simple and very efficient before sending the data through the acquisition chain in the next parts of the chain of an IoT. And in this specific case, we see that we showed an example to show you how we think we can do this. There is an hand that is holding a glass, and this glass is falling, is shaking at least. The data from the hand that are in theory the sensors are recorded in real time and transformed into event-driven data. What does it mean? That for every variation of the pressure in the sensors of the hand, we get spikes that encode the transformation. This data can be then used in different parts of integrated circuit that we develop, in which in each part you get a different ability. Specifically in this use case, we thought about four different tasks that could be useful: orientation recognition, texture recognition, movement detection, and shape detection. What does it mean? Basically, the spikes that come from the sensors that are already transformed by another circuit into spikes from analog data are fed into different networks made of neurons organized in different ways. The one orientation recognition detect the angle. The texture recognition detect which kind of texture it is. It is mainly done using exploiting the frequency of the spike rate. Then by seeing which sensors are activated one after the other, you can see the movement, and with more complex feed-forward network, you can even detect the shape. The idea here is that you could combine this different knowledge to get a better guess of what's happening. So there is a glass cylinder that is falling vertically. The glass cylinder is a glass, and this could be then implemented with a closed loop approach and have a motor saying, okay, grasp harder because the glass is falling. So this could be both a very nice thing for robots, so robots in which you have the ability to grasp things and keep holding things, which is a very difficult task. But also it could be an interesting approach for prosthetics, neuroprosthetics basically, in which instead the hand would be a prosthetic hand, and then the next pathway will be actually done by humans. So the hand will be then wired up to the remaining of the arm of the person or the foot of the person, and this could send proper data to the brain, helping the person to regain his independence. So if you are interested, come to see my poster. I'm waiting you at the ICT. Open.